Good Friday, the 27th of March, 1964. In Anchorage, the clock reads 36 minutes past 5 in the afternoon, and the light is the flat spring light of a place still thinking about winter. The shops along 4th Avenue are closing for the holiday. In the harbors to the east, at Valdez and at Seward, men are working a freighter's cargo under the same gray sky. Out in Prince William Sound, at the village of Chenega, the tide is low and the boats are pulled up on the gravel. Then the ground begins to move. It moves for 4.5 minutes. That number deserves a moment of its own, because almost nothing in the physical world lasts 4.5 minutes. In Anchorage, dishes walk off their shelves and come back and walk off again. A block of 4th Avenue drops the height of a standing man and stays down. Along 600 miles of coastline, the crust of the continent slides as much as 60 feet. When it finally stops, the shaking itself has killed very few people. Almost everyone who will die that night is still alive at this moment. They will die in water, most of them within minutes, in places where the sea arrives before the sound of the earthquake has finished rolling off the mountains. It is the largest earthquake ever recorded in North America. Magnitude 9.2. Only one earthquake anywhere on Earth has ever been measured larger, since instruments began keeping the record in 1900. The official story tells of a continent that shook and a coastline rewritten overnight. What the records reveal is stranger, and it is the reason this afternoon belongs in this series. The same event contains both halves of the warning problem, and only one of those halves was anybody's fault. Begin with the half that was not. Anchorage is the largest city in the territory, and it is built in places on a bluff of glacial clay above an inlet. Along one stretch of that bluff stood the newest and most expensive houses in Alaska, on ground with a view. 4.5 minutes of shaking turned the clay beneath them to something closer to liquid, and 130 acres of hillside moved sideways toward the water, as much as 2,000 feet in places, breaking into blocks and ridges as it went. 75 houses went with it. 4 people were killed. The photographs from Turnagain Heights are the strangest images of the whole event, because nothing is broken in the way a photograph of an earthquake is supposed to be broken. Roofs are intact. Walls are square. The houses simply are not where they were, and the ground between them has folded into ridges of clay with front doors standing in it. Downtown, a 5-story department store stood on the corner of 5th Avenue, its walls built of reinforced concrete panels. During the shaking, the northeast corner of that building came off and went into the street, and the store was damaged past any hope of repair. Photographs taken minutes afterward showed debris still falling. Those photographs became the picture of the earthquake, the one that ran in newspapers across the country, the one most people still see when the year is mentioned. Anchorage is where the earthquake was seen. It is not where the earthquake killed. The wave that killed most of the dead in Alaska was not the wave that crossed the Pacific. This distinction is the single most important fact of the day, and it is the one that almost every retelling loses. A great subduction earthquake lifts the sea floor and sends a tectonic wave outward across open ocean, traveling at the speed of a jet aircraft, taking hours to reach a distant shore. That wave was generated, and it did travel, and it did kill. The United States Geological Survey is precise about the arithmetic. Of the 131 people who died, 119 were killed by tsunamis generated by underwater landslides, not by the ocean-crossing wave at all. Those are 2 different physical events wearing the same name. Prince William Sound is a drowned mountain range. Its inlets are fjords, some of them 1,000 feet deep, and the slopes beneath the water are made of loose glacial sediment lying at an angle it can only just hold. 4.5 minutes of shaking took those underwater slopes and dropped them. A mass of sediment the size of a neighborhood slid off into a fjord, and the water it displaced had nowhere to go but up and then out, and the shore it went out toward was a few thousand yards away. The travel time was not 4 hours. In some places it was 90 seconds. At Valdez, a freighter was tied up at the town dock, and the whole waterfront was crowded with people watching her unload, because a ship arriving was an event worth walking down to see. The shaking dropped the delta the dock was built on into the harbor. Dock warehouse pilings and the people standing on them went with it. The ship rolled, tore free, and survived. 31 people at Valdez did not, which is more than any other town lost. At Chenega, the village stood on a shelf of rock above a beach, and the men had gone down to the boats. The wave came into the inlet within minutes of the shaking, and it took the school, the houses, and the boardwalk between them. Of the 68 people living at Chenega, 23 were killed, the largest share of any community in Alaska. Then there is Seward, and Seward is the town that should be remembered here, because Seward happened twice. A kilometer of the Seward waterfront slid into Resurrection Bay during the shaking. The slide generated its own local wave, and on its way out, it took the oil tanks along the shore, and the burning fuel went onto the water and stayed there. Anyone standing on that waterfront had perhaps a minute of warning, which is to say, none. That first inundation went out again, and the harbor was left burning, and the men of a fishing town did the thing that men of a fishing town do. They went down to look at their boats. 20 minutes later, the main tsunami came into Resurrection Bay, and it killed them. Hold on to that, because it happens again tonight, 4.5 hours south, to people who had every advantage that Seward did not. Down at Kodiak, the fleet was the town's entire economy, and the water came into the harbor and took it. The city's own report, filed 10 days later, counted 35 boats sunk or aground, 17 missing altogether, and 45 more damaged. Some of them were left sitting upright several hundred feet inland, in the streets, on ground where a boat has no business being, and a beached signer on dry gravel is the image the survivors of that coast describe first, ahead of any wave. There is no warning system in the world, then or now, that saves Chenega. There is no telegraph, no siren, no telephone, and no satellite that outruns 90 seconds of water. The people who died in Prince William Sound were killed by geometry, by the specific shape of the sea floor beneath a specific set of villages, in the specific minutes when the ground would not stop moving. This has to be said plainly, and said first, because of what comes next. Because the ocean-crossing wave, the slow one, the one that took hours, also killed people, and that half of the afternoon was somebody's job. The United States had a tsunami warning system in March of 1964, and it had had one for 15 years. That system had a name and an address, the Honolulu Observatory, open since 1949, with a rudimentary version running from the year before, and built for exactly this. It existed because of the 1st of April, 1946, when an earthquake in the Aleutian Islands sent a wave across the Pacific and killed 159 people in Hawaii, most of them at Hilo, hours later, with nobody watching for it. So the system was designed around a single insight. A wave crossing open ocean is slower than a telegram. That insight is correct, and it remains the whole basis of tsunami warning to this day. What the Honolulu Observatory could not do was warn anybody close to the source. Its own operating record says so. It worked for distant sources and could not move fast enough for local ones. A limitation of physics rather than of will, and the reason Alaska's own villages were beyond saving on that particular evening. The wave that left the Gulf of Alaska did cross the ocean, and it was recorded in more than 20 countries. It reached Japan. It reached Peru. It reached New Zealand. In most of those places, it arrived as a curiosity, a strange tide, something noted in a harbor log. And the reach of that afternoon went further than the wave did, in ways nobody at the time could have expected. Water sloshed back and forth in enclosed basins thousands of miles from Alaska. Harbors, lakes, swimming pools, because the seismic waves themselves passed through and set the water rocking. In Louisiana, a number of fishing boats were sunk by water moving in that way, in a state with no coastline on the Pacific at all. In Wells, in South Africa, the level of the water rose and fell. A hillside had let go in Prince William Sound, and somewhere on the far side of the planet, the water in a well went up and came back down. The coast of Oregon and the coast of Northern California are not close to Prince William Sound. They are between 4 and 5 hours away at the speed of a tsunami. For those coastlines, the system was working exactly inside the range it was built for. Follow the message. The earthquake happens at 36 minutes past 5, Alaska time. In Honolulu, the observatory does its work. It collects the seismic readings. It identifies a great earthquake in the Gulf of Alaska. It calculates arrival times down the Pacific coast, and it issues the alert. At 9:30 in the evening, Pacific time, the State Civil Defense Office of California has the information in hand. The estimated arrival at Crescent City is midnight. That is 2.5 hours of margin in a town of a few thousand people on a flat harbor front that a sheriff's department could clear in an evening if it were told. The Civil Defense Office did not tell the counties at 9:30. It did not tell them at 10 or at 10:30. The alert reached the counties at 8 minutes past 11. 98 minutes. The message did not stop because a wire fell, as it did in 1888. It did not stop because a word was forbidden, as it was in 1925. It stopped because in 1964, the warning was addressed to state civil defense offices and not to the counties. And a county is where the deputies are. The design of the chain put a full step of bureaucracy between the calculation and the car, with a loudspeaker on the roof. By the time the sheriff's deputies of Del Norte County knew, they had less than an hour before midnight. They spent it. They drove the low streets of Crescent City, and they got most of the town off the waterfront. And what they achieved in 50 minutes is genuinely impressive. What they did not have was the time to do it twice. The first wave came in a little after midnight, and it was not much. The second was smaller. The third pushed water into the storefronts along the harbor front, wetted the floors, floated some crates, and went out again. And that is the moment the night turned. A wave that disappoints teaches the wrong lesson. People came back down to the harbor. Shopkeepers went in to lift stock off wet floors. Others came to look, because water in a street is a thing worth seeing. Some of them had been evacuated an hour earlier, had now watched 3 waves arrive and do very little, and had drawn the obvious conclusion from the evidence in front of their eyes. It is the same conclusion the fishermen of Seward drew about their boats 20 minutes after the first wave, with no evacuation order and no warning system involved at all. 2 towns separated by 1,500 miles and 4 hours of ocean, made the identical judgment on the identical evidence, which suggests the judgment is not the failure. The failure is the design that leaves people alone with it. Most eyewitnesses agree that the fourth surge was the highest. It came in at close to 21 feet. It crossed the harbor, took the boats, took the front of the town, and went 4 blocks inland. 29 city blocks were wrecked. 11 people were killed. Further north, on the Oregon coast, the wave had come ashore earlier and smaller, and it found a family. Monty and Rita Mackenzie had taken their 4 children camping at Beverly Beach, and they were sleeping on the sand in a shelter built of driftwood. When the water came through, the parents held on to the children, and the water took the children out of their hands. All 4 were lost. The parents lived. They were not warned. Nobody asleep on a beach in 1964 was warned. Set the 2 halves side by side, because the whole meaning of the day is in the comparison. In Prince William Sound, the water arrived in 90 seconds and killed 119 people, and no institution on Earth could have prevented it. At Crescent City, the water arrived after 4 hours and 40 minutes. The science had worked. The arrival time had been calculated correctly to within minutes. The alert had been issued, and it sat in an office for 98 minutes. The first is a fact about the planet. The second is a fact about an organization chart. Counting the dead has the same problem it always has, and this series has learned to say so rather than pick the tidiest number. 131, says the Geological Survey. Other accounts give 136, and others 139. The regional arithmetic does not close either. The survey records 16 deaths in Oregon and California together, while the cases documented by name and by place come to 15. The 4 Mackenzie children and the 11 at Crescent City. What is not in dispute is what happened to the land, and it is difficult to hold in the mind. Montague Island came up out of the sea by as much as 49 feet. Near Turnagain Arm, the ground dropped 8 feet, and the salt water followed it inland and killed the trees, and the gray skeletons of that drowned forest are still standing today. At Portage, the subsidence let the tide into the town, and the town was abandoned. Girdwood was moved. Valdez was condemned where it stood and rebuilt 4 miles west, on ground that would hold. In one afternoon, a coastline stopped being where the maps said it was. Nor did the ground settle quickly. 11 aftershocks above magnitude 6 came in the first day alone, and 9 more over the following 3 weeks, and thousands more across the months after that. For people sleeping in cars and in school gymnasiums with the power out, the distinction between an aftershock and the beginning of another one is not available. It is worth remembering that the weeks after a great earthquake are not quiet weeks. They are weeks of being told, over and over by the floor, that the thing is not finished. This is where the story turns from what was lost to what was learned, because the Great Alaska Earthquake is the rare disaster that paid something back. Start with the institution, because the failure was read correctly, and it was read fast. In 1967, 3 years later, the Palmer Observatory opened in Alaska, built as a direct response to this earthquake and dedicated on the 2nd of September of that year. It gave Alaska what Alaska had never had, a warning center inside Alaska, watching for local sources, close enough to the coast to matter. The Honolulu system had been designed by the memory of Hilo in 1946, and it guarded faithfully against the wave that Hilo had taught it to expect. Palmer was designed by the memory of Chenega. That does not save Turnagain. Nothing saves Turnagain. It does mean that the next village on a fjord had somebody whose job was to know. Then there is the other thing, and it is larger than any warning system. In 1964, the theory of plate tectonics was not yet settled science. The idea that the ocean floor is manufactured at ridges and destroyed at trenches, and that the continents ride on it, was argued over in journals rather than taught in schools. Subduction, the specific process of one plate sliding beneath another, was a proposal with supporters and opponents. A geologist from the United States Geological Survey, named George Plafker, went into the earthquake zone and did something unglamorous. He mapped what had moved. He walked the coast and measured where barnacles now sat high and dry above the reach of the tide, and where forests now stood below it. And he plotted the uplift and the subsidence across hundreds of miles of wrecked shoreline. What came out of that mapping was a pattern, and the pattern was the answer. Two parallel belts, one of them rising, mostly offshore, and one of them sinking, mostly on land, running side by side along the whole length of the coast. Plafker looked at those two belts and said the thing that explains them. The floor of the ocean was being driven down, and under the edge of the continent, the two surfaces had been locked together, and the earthquake was the moment they let go. He was describing a subduction megathrust before the vocabulary was standard. What he mapped in Alaska in 1964 is the pattern that every modern simulation of a subduction earthquake still begins with, and it is the reason we can now say, with confidence and without drama, that the same coastline will do this again. The disaster produced the proof of the mechanism that caused it. That is the shape of this one, and it is why it sits differently in this series from the four that came before. At Johnstown, the information existed in a letter that somebody had filed. At Peshtigo, it existed as a condition so constant that it had stopped registering. In 1925, it existed in a forecaster's head and was forbidden a name. In 1888, it existed correctly, in writing, in an office in St. Paul, and it never reached a schoolhouse. Here, in 1964, it existed. It was correct. It was calculated. It was sent. And it was addressed to the wrong desk. Each of these is a different way for a true thing to fail to arrive in time. That is the subject of this channel, and the reason to keep walking through the wreckage of specific afternoons is that the failures are not interchangeable. A wire that falls, a word that is banned, a form that goes to the state instead of the county. Each needs a different repair, and a story that flattens them all into human carelessness repairs none of them. There is one more image worth holding, and it belongs to the ground rather than to any office. The 4.5 minutes of shaking released something in the order of 500 years of accumulated strain. For 5 centuries, those two plates had been locked together, moving a few centimeters a year against one another, and not slipping, storing the difference. Every one of those centuries was quiet. Villages were built and rebuilt, and a city grew at the head of an inlet, and none of it was reckless, because nothing in the ground gave any sign at all. The stillness was not safety. It was the sound of a clock being wound. No institution could have delivered that warning in 1964, because in 1964, nobody yet knew how to hear it. It became a warning afterward, out of the notebook of one geologist walking a wrecked coastline, measuring the height of barnacles above the tide. The ground had been keeping the record the whole time. It was waiting for somebody to learn to read it. That is what we go looking for here. The afternoons where the ruins are only half the story, and the other half is a piece of paper on the wrong desk. Explore with us how other disasters reshaped the world that came after them.